Assalamualaikum and good day to all students. For this video, we are going to cover for chapter 7 of FST209, whereby the topic for this particular chapter is fluid mechanics. Alright, so we are going to begin our slide, our PowerPoint presentation slide now. Okay, so first thing first, we need to be introduced what is fluid mechanics. Fluid mechanics is a branch of science which deals with behavior of the fluids, either it is involving with the liquid or gases at rest as well as at motion. When we talk about fluids, okay, fluid is not only for liquid, it also apply for the gases as well. And a fluid also can be used for the solids that behave like a liquid. For example, when you pour flour from one container to another container, the flowing movement of the flour is similar like the liquid movement, right? So for this particular fluid, do not restrict yourself when we talk about fluid is only meant for liquid. It is wrong, whereby this particular fluid, it also covers for the gases as well. Alright, for fluid mechanics, it may be divided into three parts. The first one, whereby we call it as statics. Statics is whereby the fluid is not moving from the in any part of the area. So fluid static is the study of incompressible fluid under static condition, whereby it is known as hydrostatic. Okay, incompressible fluid, for example water, you cannot compress water. However, for gas, we can compress gas. That's why we have compressed gas. However, for liquid, for water, basically it is a non-compressible. It cannot be compressed. So this the first part of fluid mechanics is known as fluid statics. And then the second one is fluid kinematics, whereby it deals with translation, rotation, as well as deformation of fluid elements without considering the force and energy causing such a motion. For example, when the fluid is being stirred, so that one it is known as a fluid kinematics. Okay, and then the third part of the fluid mechanics is known as a fluid dynamics, whereby this particular fluid dynamics, okay, it deals with the relation between the velocity of the liquid, meaning that the fluid is moving. Okay, it deals with the relation between the velocity, acceleration of fluid with the forces of energy which causing them. Okay, so for static, meaning that the fluid is non-moving and they are non-compressible, whereby for dynamics, the fluid is moving from one part to another part, from one section to another section, and it deals with the velocity of the fluid together with the acceleration of the fluid, and followed by with the forces of energy that cause the movement of the fluid. Okay, so for this particular chapter, we are going to cover for fluid statics as well as fluid dynamics. We are not going to cover for fluid kinematics for diploma level. Alright, now we are moving to the next slide. For fluid flow, what is the definition of fluid? Fluid is a substance which is capable of flowing. Okay, any fluid, basically they are able to be flowed and deforms continuously when subjected to external shearing force. Okay, deform meaning that the fluid, it is able to follow the shape of the container or the tubing that they are flowing. Okay, so that's why it can deform, and also together with the shearing force. For example, the fluid, when it is static, it is viscous. But then when it starts to be mixed, or there is a shearing force, it starts to become thinning. Okay, it is become less viscous. So it starts to deform. So that one is a fluid flow. Okay, many raw materials for foods and finished food products are in the form of fluid, And these particular fluids, the study of the fluid flow is important because these particular fluids, they need to be transported and processed in the factory. So we need to know how to design the equipment or the piping in order for this particular fluid to be able to be transported, or it is to be able to be processed without so much resistance towards the fluid flow. Okay, characteristics of fluid, it has no definite shape on its own. Okay, for fluid, of course, they don't have their own definite shape, but then it will follow to the shape of the vessel or the container that contain that particular fluid. If let's say the container is a square, then of course the fluid will follow the shape of the container. If the container is round, then it follows the shape of the container as well. Even a small amount of shear force exerted to the liquid, okay, shear force given, when we talk about exerted, this one also is can have another meaning as is given. When we give shear force to the liquid or fluid, it will cause it to undergo a deformation. Deformation meaning that it changes in terms of its characteristic, which continues as long as the force continues to be applied. Okay, this one I've mentioned just now. When we form this shear force, it can become thickened or it can become thinning. Thinning meaning that this one is a more viscous and this one is less viscous. Okay, when we apply mixing or rotating of that particular fluid, so it depends on the characteristics of the fluid. Okay, and then another characteristic of fluid, the third one is resistance of deformation. Of course, at first, fluid, they will have their own resistance towards deformation, meaning that when you start to rotate the liquid, at first, the fluid will resist to follow the direction of the shearing force, but then when it already overcome the resistance of the shear force, then that particular fluid will start to deform. Okay, number 4, level of compression. Level of compression, this one, it really goes for the fluid that are able to be compressed. Okay, when we talk about water as a part of a fluid, water is non-compressible. It cannot be compressed. However, when we talk about gas, for example, CO2 or oxygen, they are able to be compressed. So what is the level of compression for that particular fluid and which type of fluid that we are talking about, which we are referring to. Okay, so then we move on to the classification of fluids. The first one, we have a thin liquid. Thin liquids meaning that it is less viscous. Okay, so we have a water, milk and fruit juices. And then the second classification, we have a thick liquids. So for this particular thick liquids, this one involving with honey, syrups, oils and jams. And this particular example is basically in the food industry because we are learning about food engineering. And then for gases that normally being used in food industry, normally will be compressed air or filtered air, followed by nitrogen, carbon dioxide, and other types of gases. Last but not least is a fluidized solid. Okay, this one is what I'm talking about just now. Remember, fluid is not only for liquids and gases, it is also meant for fluidized solids, whereby this particular solid, when we pour or when it is moving, it behaves like liquid. So for fluidized solid, this one, it goes for the grains, flour, peas, sand, and other types of fluidized solid that can move like when it is moving, it is like a liquid. Okay, now we move on to the relationship between pressure and height, absolute pressure, as well as gauge pressure. Okay, these particular terms are associated with the measurement of fluid pressure. When we talk about atmospheric pressure, this one, it relates with the pressure that is being given by atmospheric air, meaning that it is at atmosphere, the level is at 1 atm, okay, 1 atmosphere, upon all surfaces which it is in contact. it varies with altitude. Okay, if let's say you go to the higher level, then the pressure will be different. If let's say you go lower than the ground level, the pressure will be different as well. So when this particular atmospheric pressure, it is also known as barometric pressure. Then the second term of pressure, fluid pressure, this one is absolute pressure. Absolute pressure scale is independent of the changes in the atmospheric pressure. Okay, meaning that this particular absolute pressure does not change according to the altitude. Pressure measured from the state of vacuum normally is called as absolute pressure. Okay, this particular pressure, it occurs in a vacuum state. For example, when you have a condition of the vessel in a vacuum state, then what is the pressure? That pressure given by that particular vessel is known as absolute pressure. Then we have gauge pressure. For the third one is gauge pressure. It is the pressure measured with the help of pressure measuring instrument. When we talk about gauge pressure, we need to rely to the instrument. Atmospheric pressure is taken as the datum. When we talk about datum, datum is always referring to the reference. Okay, reference of the pressure. Gauge pressure can be either above or below atmospheric pressure. So this is the relationship between absolute pressure, atmospheric pressure, and gauge pressure. Absolute pressure is equals to the value of atmospheric pressure plus minus with gauge pressure. Okay, atmospheric pressure, it really depends on the height of the Earth's surface, whether you go to the altitude. So this one, it depends on the altitude. For the atmospheric pressure at sea level, basically we are referring to 1 atmosphere, or it is also being known as a 101.325 kilonewton per meter square. Okay, and if let's say we rearrange the equation of the pressure, for example, we have 4 sides of area. Okay, so basically for PB, pressure for B area is equivalent to pressure for C area. Then if let's say pressure for B is equals to the pressure of A plus with pressure referring to the height of water, then the pressure for B area is equivalent to pressure of A plus H rho G for H2O. Okay, this particular H rho G, I believe you have learned in physics during your secondary school. Okay, this one is referring to the pressure that depending on the altitude. Okay, and then for the second condition, if let's say the pressure of C, now we are talking about this one. So for PB, we have settled for this one. Now we move on for PC. Okay, if let's say the pressure for C is equivalent to the pressure of area D plus pressure referring to the height of Mercury. Okay, Mercury, basically this one is the reference. So pressure for D area is equivalent to atmosphere pressure equals to absolute pressure. Absolute pressure, basically it doesn't have any value. So PC equals to 0. Okay, for this particular pressure for D is 0 plus H rho G for Mercury. Okay, the first one is for H2O, for the second one, this one is Mercury. So since PB, pressure for B, is equivalent to pressure of C, then when we rearrange again this particular equation, we rearrange over here, then PA, because PB is equals, this one is PB, right? So this particular PB, we bring it over here. Okay, PB equals to PA plus H rho G for water. And for this particular PC is from here. So we put it over here. Okay, so for PC is H rho G for Mercury. Then when we want to calculate for the pressure of A area of A, then it becomes the gravitational acceleration times by the H rho g for mercury minus by H rho g of the height of the water. Okay, so now we move on to the next slide. This one is for rheological properties of fluid foods. This one, it is according to the power law, whereby tau is equals to K sigma to the power of n. Alright, this one is the fundamental definition of viscosity. Okay, this one, it is known as a fundamental definition of viscosity. Oops. Definition for viscosity. Okay, so this one is known as tau. This one is K, is the consistency coefficient, gamma, and this one is to the power of n. So tau is the shear stress, whereby the unit is in Newton per meter square. Gamma is a shear rate, whereby the unit is in per second. N, this one, is the flow behavior index. It really depends on type of the liquid, the fluid. And K is consistency coefficient, whereby this one is in unit of Pascal second to the power of n. Okay, so we have several types of fluid where when it is being subjected to shearing force. How does that particular fluid behave? So the first one, we have pseudoplastic. Okay, pseudoplastic, for example, juice, yogurt. The value for n is in between 0 to 1. Okay, and then the second characteristics of fluid is Bingham pseudoplastic. Okay, the value for n is less than 1. The third one, we have Bingham plastic. Okay, this one, Bingham plastic. This particular value of n is equivalent to 1. For example, of Bingham plastic is tomato ketchup. And then dilatant. The fourth characteristic is dilatant. For example, starch. When we mix starch with water, at first it is thin, but then when you keep on stirring the mixture of starch plus water, then it will start to become thickened. So that one is known as dilatant, whereby the value of n will be greater than 1. Last but not least, the characteristics of fluid is classified as Newtonian, whereby Newtonian is water and n is equivalent to 1, whereby for this particular Newtonian behavior, alright, when we talk about behavior of the fluid, we will talk about whether it is a Newtonian or non-Newtonian. From 1 until 4, okay, from 1 until 4, this one, it is known as non-Newtonian fluid. Okay, whereby for the fifth behavior, this one is known as Newtonian fluid. Okay, when we talk about Newtonian fluid, meaning that how regardless of how much force that you given to the water, for example, it doesn't matter whether you stir the water at slow speed or high speed or at short time or longer time, it will not change in terms of the viscosity. Okay, that what does it mean by Newtonian fluid. However, for the behavior number 1 until number 4, this particular behavior of fluid, they will really depending on the time, temperature, as well as the shearing force, meaning that how much force that you given to stir that particular fluid or to move that particular fluid. So this particular behavior, it will having an effect towards that shearing force as well as the time of shearing. Okay, and then we talk about C. For this particular equation, we have C. C, this one is referring to the yield stress, whereby the stress which shall be overcome before the fluid can start to flow. Meaning that when we want to pour or we want to move the fluid, we need to have an additional shearing force in order to overcome the stress of the fluid. Then only the fluid will start to flow. Otherwise, it will become static. Alright, so this particular graph, it's showing the behavior of that particular fluid. For number 5, this one is a Newtonian fluid. Okay, and for number 1, check again in the previous slide. Number 1 is pseudoplastic. Pseudoplastic is, for example, juice or yogurt. Okay, when we talk about shearing rate, there will be an increase in terms of their shearing stress, and the shear rate will increase as well. So this is the relationship between the shear stress and shear rate of fluid. Okay, now we talk about fluid statics. For fluid statics, it is a very important property for fluid at rest, meaning that it is not moving. Okay, when we talk about a fluid at rest over here, meaning that it is not moving, is the pressure exerted by the fluid on its surrounding, meaning that the pressure given by the fluid to its surrounding. When you put water inside a container, for example, there is a pressure given by the water to the container, as well as the atmosphere pressure given to the water inside of the container. So there are several types of pressure involved. Pressure is defined as a force exerted on an area A. So for pressure, it can be notified as force divided by A, area. The magnitude of force is equal to the mass of the material multiplied by the acceleration due to gravity. So when we talk about force, force is equals to m times by g, whereby m is the mass, g is the gravitational acceleration, and this particular m, it can be calculated as v times by rho. Okay, whereby v is the volume, rho is the density, and g is the gravitational acceleration. Okay, because when you calculate this v times by rho, you will end up to get the unit as the same as mass. Mass is in kilogram basically. So F is the force exerted, and the unit is kilogram meter per second square. M is the mass, so basically the mass is being denoted by in kilogram. The unit will be in kilograms. We are talking about SI unit over here. G is the acceleration due to gravity or gravitational acceleration. Rho is the density of the fluid. For a mass to remain in equilibrium, okay, meaning that it is having the same pressure from the inside and outside of the area, the force it exerts due to gravity must be resisted by supporting medium. For example, when the weight is resting on a table, or for example, when you are sitting on a chair. So from the bottom part, there is a pressure from the gravity, and you yourself is having your own mass. Your pressure is going downward, whereby the gravity going upward. So the table or the chair will provide the supporting reaction. Okay, so then we move on for the fluid in the tank, for example. Okay, total force per unit area, F, is can be calculated by A times by PA, the area of the A, okay, plus Z rho AG. Okay, this one Z is the height basically. Rho is the density, A is the area, G is the gravitational acceleration. So total pressure P equals to F over A. So since P equals to F over A, so this particular P you can replace in the equation and rearrange the equation. So F over A equals to PA plus Z rho G, because this particular A and this particular A, it can be cancelled out when it is bring it over here. Okay, where PA is the pressure above the surface of the fluid. For example, it might be atmospheric pressure. Z is the depth of the fluid below the surface, is the depth or the height of the fluid in the tank. A is the area of the plane. ZA is the volume. When we talk about Z times by A is the volume of fluid. lying above an area of A. And when you talk about ZA rho, this one is the mass of the fluid. Then we move on for the Newton's law of viscosity. Newton's law of viscosity, what does it mean by viscosity? Newton's second law of motion, it is a resistance, a force that is offered by the fluid to movement in the opposite direction to the shearing force, and it also acts in the direction parallel to the surface between layers. Okay, for example, you have several layers of fluid. When the fluid flow, actually the fluid itself, they have several layers, but of course it cannot be seen by naked eye. So when the top part of the fluid is moving, actually the bottom part of the fluid is resist to move to this direction. Okay, when one part, the top part is moving to the right, the bottom part moving to the left, because it resists to follow the direction of the top part of the fluid. However, when you have a certain force, okay, when you have a certain force and that particular force has overcome this particular resistance, then of course the bottom part will follow the direction of the top part of the fluid to flow according to the direction. Okay, so the resistance of force, okay, this particular resistance, this is known as a viscosity. Okay, whether it is you require a low force or high force in order to move the fluid, the relative movement of one layer of fluid over another due to the force, that one is known as shearing force. Okay, for viscosity, it is the property of fluid which give rise to the forces and resist the relative movement of adjacent layers in the fluid. If two parallel elements, this one what I have shown just now in previous slide, if two parallel plane movement in a fluid are moving relative to one another, it is found that a steady force must be applied. Steady force meaning that you need to maintain the amount of force given to the fluid in order to maintain a constant relative speed of the force. Okay, for example, when we want to transport the liquid from one section to another section, it needs to have a steady force in order to maintain a constant relative speed of that particular fluid. Otherwise, it may not be moved. This force is called as a viscous drag, okay, because it rises from the action of viscous forces. So basically device to measure fluid viscosity is known as a viscometer as well as a rheometer. Viscometer, this one, it can only calculate for the viscosity of the fluid, whereby for rheometer, this one, it can study the characteristics as well as the behavior of the fluid. For the unit of viscosity, dimensional of viscosity, it is always associated with Newton second per meter square, or it can be used the unit of Pascal second or kilogram per meter second. Okay, so this is what in the previous slide mentioned, when we have two plane element of fluid, we need to have this particular steady force, okay, this particular force to maintain the movement of the fluid, of both fluid at the top part and at the bottom part. This particular Z, this one is the depth of the fluid. Basically, when the top part is moving, the bottom will not follow in the initial part unless a steady force has been given, and only then both of this particular fluid in a plane surface, it will start to move. Now we move on to fundamental definition of viscosity. This one we have mentioned also just now. F over A equals to V mu over Z, whereby A is the area over which a force is being applied, and it can also be written as F over A equals to V mu over Z. It is also equivalent with mu towards the changes of dV dz, and this particular equation, it is represented by tau. Tau is the shear stress in the fluid. Now we move on to the consistency of the fluid. Consistency may be considered as a textural quality attributes. So this one, viscosity as well as consistency, it is an important characteristics of a fluid. So for this particular consistency, this one relates to the textural quality attributes. So for consistency, it gives another factor for food appearance. Consistency of foods, basically it is being measured by their viscosity at certain set of temperature, okay, or shear rate. For example, when you maintain the temperature at 25 degrees Celsius, but then the shear rate will be different. So that one will give different value of consistency. Higher viscosity of products being higher consistency, and lower viscosity of products of fluid, meaning that they are having lower consistency. And again, for the dimensional of consistency is similar with viscosity, whereby the unit being used for measuring consistency is Newton second per meter square. Consistency is resistance to the rotation. Okay, this one is a rotation of a spindle. Okay, spindle meaning like your mixer attachment, or resistance for the fluid to flow. Okay, this graph, it shows the relationship between the temperature as well as the viscosity. For example, some of the fluid, when we increase the temperature, okay, when the temperature increase, okay, can you see that the viscosity getting lower at this particular site? So this particular value is known as consistency. Alright, so these are the instruments that are being used to measure viscosity. So this one is a viscometer, this one also is viscometer. And can you see this particular set of steel rod? This one is known as spindle. This particular spindle, it will rotate. Okay, this particular spindle, it will rotate and it will measure the viscosity of the fluid, of the sample of the fluid that we want to measure. So for example, this one is the sample of the fluid that we want to measure. So the spindle, it will start to rotate and it will measure, and the value of viscosity will appear on this particular display.